You're standing on a rocky riverbank in the far north of Australia, and it's the middle of the night. At your feet lie dead cane toads, not crushed, not chewed, each one flipped neatly onto its back, the chest opened with a single clean incision, the heart and liver gone, the skin untouched, the poison untouched, only the safe parts taken. Something out here learned how to kill the one animal in Australia that nothing is supposed to be able to eat. It cuts into it like a surgeon in the dark, removes the exact organs it wants, and leaves the venom behind. And the thing doing it is not the crocodile, the snake, or the bird of prey that everyone assumed. It was never what we thought. I found the proof buried in a study published in a journal called Australian Mammalogy, tied to a single stretch of the Ord River near a town called Kununurra. This is not a legend passed around campfires. It is documented, measured, and photographed. And by the end of this, you'll know the name of the creature that outsmarted Australia's deadliest invader. I remember the exact moment it grabbed me. It was almost 2 in the morning, and I was scrolling through field photographs from Western Australia when one image stopped my thumb cold. A cane toad, belly up on a flat stone, opened along the breastbone with an incision so precise it looked done with a scalpel. I actually leaned toward the screen and said out loud, who did that? And I could not put my phone down for the rest of the night. Because that single question breaks something in your head once you understand what a cane toad actually is. To understand why those clean little incisions are almost impossible, you have to understand the animal lying on that rock. You have to understand why, for 80 years, this toad has been a death sentence for anything that dares to bite it. Let me take you back to 1935. That is the year the whole nightmare began in a sugar town in Queensland called Gordonvale. Australia's sugarcane farmers were losing their crops to a beetle, the greyback cane beetle, whose larvae ate the roots of the cane. Someone had an idea that sounded brilliant on paper. In Hawaii and in Puerto Rico, there was a big, hungry toad that supposedly gobbled up beetles. So they shipped a batch of them across the Pacific. About 102 toads arrived alive. They were bred in captivity, and within a year, roughly 2,500 young toads were released into the cane fields. It was a catastrophe from the very first season. The beetles lived at the top of the cane stalks and flew. The toads could not climb and could not fly. The one job they were brought in to do, they could not do at all. But they could breed. A single female cane toad can lay up to 30,000 eggs in one clutch. Think about that number, 30,000, and they will eat almost anything that fits in their mouths, from insects to small mammals to dog food left on a porch. So they spread slowly at first, then faster and faster. Today there are hundreds of millions of cane toads across Australia, and the front line of their invasion pushes west and south by as much as 60 kilometers every single. When they first started spreading, they moved about 10 kilometers a year. The toads on the leading edge have evolved longer legs and travel farther night after night. They are still advancing right now, tonight, into country that has never seen them. But the reason nothing stops them is not their numbers, it's their chemistry. Behind each eye, a cane toad carries a large gland called the parotoid gland. When the toad is threatened, that gland oozes a thick, creamy poison packed with compounds called bufadienolides. These toxins attack the heart directly. A native predator that has never encountered a cane toad, a quoll, or a goanna, or a freshwater crocodile, or a snake grabs the toad the way it grabs a native frog, and within minutes, its heart seizes and it dies. And here is the part that made this invasion so devastating. Australia's predators had no history with this animal. They had no instinct to avoid it. In the tropical north, when the toad front swept through the northern quoll, a small spotted marsupial was nearly wiped out in region after region. Populations of goannas crashed. Freshwater crocodiles were found floating dead, with toads still in their throats. The toad did not have to fight anything. It just had to be eaten once. So imagine the picture that had built up in scientists' minds by the early 2000s. The cane toad was the untouchable invader. To eat one was to die. The only creatures that could survive a toad were a handful of specialists, like the meat ant, which is immune to the poison, or the keelback snake, which can tolerate small doses. Everything else that tried died. That is the world I had in my head when I saw that photograph. A world where nothing native was supposed to be opening up cane toads with surgical cuts and eating their insides. Therefore, when I saw a toad neatly dissected on a rock, my first thought was not nature found a way. My first thought was that somebody was faking it. That there had to be a human explanation. A knife, a prank, a mistake in how the photo was labeled. I was wrong about that, and finding out how wrong took me down a hole I did not climb back out of for a long time. The trail led me to the Ord River in the Kimberley region of Western Australia near the town of Kununurra. This is remote country, red rock, and slow green water crocodile country. Cane toads reached this area only recently in the years around 2011 and 2012, riding the invasion front westward, and not long after they arrived, something started happening along the water at night that nobody could immediately explain. Field researchers and locals began finding dead cane toads scattered along the banks and on the flat rocks by the river. But these were not toads that had simply died. Each one had been carefully turned over onto its back. Each one had a small, clean incision cut into the chest or the belly, and when people looked inside, the same organs were always missing: the heart, the liver. Sometimes the gallbladder had been carefully avoided or removed. The muscular back legs were often eaten too, but only after something had peeled the skin away first. The precision is what stopped everyone cold. This was not a random tearing. It was not a bird stabbing wildly with a beak. Whatever did this was making a decision about where to cut, opening the toad in a specific place, reaching in, and taking exactly the two most nutritious organs while leaving the poison factory behind. And it was doing it over and over, night after night, on the same stretches of river. I need you to sit with how strange this is. The cane toad's defense is not a shell or claws or speed. Its defense is that eating it kills you. And here was a creature that had somehow figured out that the danger was in specific places, the skin and the glands, and that the treasure was in specific places, the heart and the liver, and had learned to separate the two with a cut. That is not brute force. That is knowledge. So who was the surgeon? That is exactly the question that consumed me, and it's the question the researchers had to answer too. And every time I thought I had a suspect, the evidence pushed back. My first guess was a bird. Australia has clever birds, and some of them do handle cane toads. There are documented cases of certain crows and ibis learning to flip toads onto their backs to attack the belly, where there is less poison, and even of some birds flushing the toxins out. So maybe I thought a raven was doing this at dawn, but the pattern did not fit a bird. The kills were happening at night. The incisions were low and precise and consistent, made from the underside, not the ragged stabbing of a beak from above. And birds do not carefully remove a gallbladder to avoid tainting the meat. This was something with hands, or something with the dexterity to work like it had hands. Something that came out in the dark by the water. Now, I want to stop here and talk directly to the part of you that is doing exactly what I did, because I can feel the skeptic in you, the same skeptic that lived in me for months, and if I don't answer that voice, you will click away so certain there's a boring explanation. So let me give that voice the floor. The obvious, boring answer is scavenging. The rational explanation goes like this. Cane toads die all the time. From cars, from heat, from fights, from natural causes. Their bodies pile up. Then ordinary scavengers, rats, ants, birds, come along afterward and eat the soft insides first, because the soft insides are always eaten first in any dead animal. The heart and the liver are soft and rich, so of course they'd be gone. The skin is tough and unappealing, so of course it'd be left. There is no surgeon, there's just a dead toad and a hungry rat that ate the easy bits. Case closed. I genuinely wanted that to be the answer. It's clean, it requires no mystery. It's the explanation I could have told myself and gone to sleep, and for a while I did believe a version of it. But the evidence broke it apart piece by piece, and I want to walk you through the exact point where it collapsed for me, because that is the moment this stopped being a curiosity and became an obsession. Here is what a scavenger theory cannot explain. First, the toads were being deliberately flipped onto their backs before being opened. A dead toad does not land belly up. Something was choosing that position, because from the back, the poison glands are in the way, and from the belly, they are not. Second, the incisions were consistent, made in the same place, toad after toad, as if following a template. Random scavenging is messy and varied. This was a repeated technique. Third, and this is the detail that ended the debate in my mind, the animals were choosing which toads to attack and how based on the toad's size, and they were peeling the toxic skin off the legs before eating the muscle underneath. A scavenger eating an already dead toad does not skin it first. That is preparation, that is a method. And fourth, the freshness. These were not rotting carcasses picked over days later. These were fresh kills, sometimes several appearing in a single night on a single site, with the surgery done cleanly and the killer long gone by morning. This was not cleanup after death. This was the cause of death. So the boring answer died on that riverbank, the same way it died for the scientists who finally sat down to study it. And when they identified the creature responsible, it was not a bird, not a reptile, not a big famous predator. It was an animal that most people, even in Australia, have never heard of. And its name is the rocali. The rocali is a native Australian water rat. Its scientific name, Hydromes chrysogaster. And I know the word rat makes you picture something small and grubby, so let me correct that picture immediately. This is one of Australia's largest native rodents. A big one can be over 60 centimeters long from nose to tail tip and weigh up to about 1.5 kilograms. It has a sleek, waterproof coat, often dark on top with a golden or orange belly, a broad flat head, and partly webbed hind feet. It is a semi-aquatic hunter, the closest thing Australia has to an otter. It has lived along these rivers for tens of thousands of years, hunting fish, crustaceans, mussels, and frogs by night. And that last word is the key. Frogs. The rocali is an expert amphibian hunter. It already knew, deep in its instincts and its skills, how to catch a slippery, jumping, water-loving target and how to handle it. So when a brand new amphibian arrived on its river, a big fat toxic one, the rocali did not react like a naive predator lunging blindly. It reacted like a specialist encountering a new problem. The study I kept coming back to, published in Australian Mammalogy, was led by a researcher named Marissa Parrott, working with colleagues, and it laid out what the rocali were actually doing with a precision that gave me chills. They examined the dead toads along the Ord River near Kununurra, and they mapped the wounds like a coroner mapping a crime scene. What they found was not scavenging. It was a surgical strategy tuned to the toad's own anatomy. The rocali were flipping the cane toads onto their backs. From that position, they made a precise incision through the chest and abdomen, avoiding the poison-loaded skin and glands on the back and around the head. Then they removed and ate the heart and the liver, the two organs richest in energy and nutrients, and the two organs that sit safely away from the toxin glands. They ate these clean. The poison stayed in the skin. The poison stayed in the glands. And the rocali walked away unpoisoned and well-fed. But it goes further, and this is where I actually sat back from my desk. The rocali were not treating every toad the same. They were making choices based on size. For the larger toads, the ones with the most dangerous concentration of toxins in their skin, the rats focused on the internal organs, the heart and the liver, and they carefully peeled the toxic skin away from the powerful thigh muscles of the hind legs before eating that meat. They were dissecting the animal, separating poison from protein with a technique that looks, when you read the wound descriptions, exactly like a butcher removing the parts you don't eat. For smaller toads, whose toxin load was lower and less deadly, the rats were more willing to eat more of the body. In other words, this animal was beyond the risk. It was calibrating how much of the toad to eat based on how poisonous that particular toad was likely to be. That is not instinct blindly firing. That is a working understanding of the enemy. And now I have to give you the number that turned this from a fascinating study into the thing that kept me up at night. The part that, once I understood it, I could not stop thinking about. The cane toads had only reached this stretch of the Ord River a very short time before. We were talking about the toad front arriving in that region in roughly 2011 to 2012. And by around 2014, when researchers documented this behavior in detail, the crocodile were already performing this surgery with skill and consistency. That means the water rats went from never having seen a cane toad in their entire evolutionary history to systematically dissecting them, avoiding the poison, and targeting the exact organs in a span of only about 2 years. 2 years. Let that sink in. Predators like quolls and goannas that had been in Australia for millions of years met the cane toad and simply died, because their instinct told them to bite and swallow. But this native water rat, in the space of a couple of breeding seasons, cracked the puzzle that had killed everything else. It looked at the untouchable invader, the animal engineered by chemistry to be a death sentence, and it found the seams. It learned where the poison lived and where it didn't, and it turned Australia's deadliest invader into a nightly meal. The researchers even recorded just how routine it had become. On some sites, they were finding multiple freshly killed and expertly opened toads in a single night, laid out on the same flat rocks by the water, as if the river had its own quiet operating theater running after dark. As many as 5 carcasses in one night on one spot. Neat rows of turned-out toads, hearts and livers gone, poison left glistening and untouched in the skin. And this is the part that finally made me angry, in the way that only a good mystery can make you angry once you see how long the answer sat in plain sight. Because for years, the story we were told about the cane toad was a story of pure defeat. The narrative was that this invader was unstoppable, that native Australia had no answer, that our predators were too naive and the toad too toxic, and that all we could do was watch the poison spread west and mourn the quolls and the goannas as they vanished. That was the official mood, doom. And the explanation never fully sat right with me, even before I understood why. Because nature is not usually that one-sided for that long. Something almost always adapts. And here was the evidence that something had adapted brilliantly, right on schedule, on a river in the Kimberley. Yet the crocodile was barely part of the conversation. This shy, nocturnal, golden-bellied water rat, an animal so overlooked that most Australians could not tell you it exists, had quietly done what an entire continent of famous predators could not. And almost nobody was talking about it. It's not that anyone hid it on purpose in some grand conspiracy. It's something quieter and, honestly, more frustrating. The crocodile is not charismatic. It's a rat, by name and by shape, and rats don't get headlines the way crocodiles and quolls do. It hunts at night, out of sight. Its victories happen in the dark, on remote rivers, witnessed by almost no one. So the single most hopeful discovery in the entire cane toad disaster, the proof that native Australia was fighting back and winning on at least one front, got filed into a specialist journal and left there, while the doom story kept running. The people who could have made this front page news mostly looked past it, because the hero was inconvenient. The hero was a water rat. But once you know to look, the picture keeps getting richer, and it keeps supporting the same conclusion. The crocodile is not the only native animal learning. Remember those crows and that ibis I mentioned. Some Australian crows have learned to flip toads and go for the tongue and the guts through the belly, avoiding the glands. Certain water birds have been seen stressing toads until they release their toxins, then rinsing the bodies in water before eating them. There are reports of native species along the older parts of the invasion front slowly recovering as individuals that avoid toads survive and pass on that caution. The continent is adapting. It's just doing it slowly, quietly, animal by animal, in a way that doesn't make a dramatic headline. And the crocodile sits at the very front of that adaptation, the sharpest example of it. But before I take you deeper into what that means for the invasion front, I want to tell you about something I've been building for exactly the kind of person who followed me this far down the rabbit hole. I've written a series of books, First Threshold, Deep Signal, and Hidden Systems, that go into cases like this one in far greater depth than a single video ever can. The primary sources, the coordinates, the field data, and the reasoning that connects them. If you've been sitting here thinking, I want more of this, the link is in the description, and you can get all three for $97. Now, back to what that adaptation actually means on the ground, because the implications run deeper than most people realize. Think about what that means on the invasion front. In places where the toads are densest and every native predator is dying, the water rat has, in effect, a nearly unlimited food supply that no competitor can touch, because no competitor has solved the poison. The very thing that makes the cane toad a catastrophe for everything else, its toxicity, makes it a private buffet for the one animal clever enough to open it correctly. I keep coming back to that image of the toad on its back with the clean cut down the chest, the same image that stopped me at 2 in the morning. When I first saw it, it looked like something sinister, almost surgical in a way that made my skin crawl, the kind of picture people build alien encrypted theories around. Mysterious mutilations by the water in the dead of night, and the truth turned out to be stranger and better than any monster story, because the truth was intelligence. The truth was a small native animal, older than the whole invasion, quietly performing precision surgery on the thing that was killing its world and getting better at it every night. Here is the detail I want to leave burned into your memory, the one pulled straight from that fieldwork on the Ord River. It's not just that the racali eats the heart and liver, it's the skinning. For the biggest, most poisonous toads, the water rat peels the toxic skin off the thigh muscles before eating the meat, the way you or I would peel a fruit we knew was rotten on the outside and perfect within. No one taught it. No parent rat could have known this technique, because no racali in history had ever met a cane toad until a decade ago. Each animal, or each small population, had to solve it almost from scratch, and they solved it in about 2 years. That is a mind at work in the dark, and we very nearly never noticed. That's what this whole descent taught me. The story we're handed about nature losing is often just the story of us not watching closely enough. The cane toad was never truly untouchable. It only looked that way from a distance, in daylight, in the headlines, down at the water's edge, at night, on the red rocks of the Kimberley. Something had already found the answer and was living off it. We were told the invasion had no natural enemy. The real answer was standing in the shallows the whole time, gold-bellied and silent, holding a scalpel. It grew itself. If you've made it this far, you're the kind of person I made this for. The kind who hears nothing can stop it and quietly refuses to believe the case is closed. The kind who wants to know who really opened the toad on the rock and won't accept it just rotted as an answer when the evidence says otherwise. So let me ask you something specific, and I actually want you to answer. Knowing now that this water rat learned to dissect Australia's deadliest invader in about 2 years, flipping it, cutting it, avoiding the poison, and taking the heart, do you think we've badly underestimated how fast wild animals can learn? Or does it frighten you a little how much intelligence is out there working in the dark where we never look? Tell me in the comments. And tell me where in the world you're watching from, because I read them and I want to know how far this story is traveling. If this pulled you in, stay with me, because this channel exists for exactly these cases, the ones everyone else filed under solved or hopeless and walked away from. We chase them down to the primary sources, the field reports, the journals, the coordinates, and we drag the real answer back into the light. There's another one I'm deep inside right now, a creature reported from the cold water off a coastline where, according to every official record, it should not be able to exist at all. Follow me, and you'll be there when I open that file. Because the cases everyone else closed are exactly the ones still waiting to be solved. I'm about to leave you right at the water's edge, but the story doesn't end here. Inside the Unexplained Society, members get the deeper version. The surgeon predator revealed on the Ord River. In there, you can ask me your own questions, and I answer you myself. A real person, not a machine. You belong here with us. Just point your phone at the code on screen. Cancel anytime. I'm Roy. Come join me. Now, if this surprised you, Wait until you see what's happening in Florida. Something is swallowing giant pythons whole, and the footage will leave you speechless. That story is starting right here, so stay with me.